Welcome back, everybody. This is XFiz Guy here with another lesson today on electrocardiogram interpretation. I did a video before talking about the very introduction of the electrical current as it pertains to the anatomy and the readout on a sheet of EKG paper. Now, as it's drawn up here, you will notice on the whiteboard there are black lines on the grid and there are red lines on the grid. Now, on your actual EKG readout, it's not going to look like this. It's going to look like a piece of grid paper that's just going to have every line is going to be black. But I will show you in a second why I have the lines marked off as black and as red. As I've stated in previous videos, you should be pretty familiar with this readout. This is a quote-unquote normal readout of most leads you will find on an EKG. I do a video where I will cover what the different leads look like and why we would look at different leads on a 12 lead. But for this video, assume we're looking at just one lead, or in other words, one view of the heart. So your first wave would be your P wave, followed by your QRS complex, and then followed by a T wave. You'll notice some darker red on the board here. That's just because I messed up drawing. Don't take that as those aren't markers or measurements or anything like that. So this video is about how we would measure waves and how we would measure intervals. And I thought it would be easier if I marked off the black and the red lines. Now on your grid paper also, it's going to be much smaller than this. This is obviously not drawn to scale. But you can think about what you will see on the grid paper is you'll see more solid black lines and more faint black lines. And that's not on purpose, so it's a little bit easier to count and measure for you. Now, sometimes the EKG machine, when it gives you the EKG, it'll give you an interpretation, but you always should have that read by a cardiologist or MD on top of that. Never take just the machine's word. So, two important things to know about when you're looking at a sheet of EKG paper is it always should be calibrated for voltage and for speed. The standard speed is 25 millimeters per second. Okay, and that's measured with these boxes. And the standard calibration is 1 millivolt equals 10 millimeters. So over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 millimeters is 1 millivolt. All right. When we measure for the length of whether it's a wave or an interval, so if I'm looking right here, where my pointer is, each little box is 0.04 seconds. 0.04 seconds. Each quote-unquote big box, now watch this, little box, big box. Each little box is 0.04 seconds. Each quote-unquote big box is 0.2 seconds, or 200 milliseconds. And that's going to be important once you start measuring things like PR intervals, QRS complexes, QT intervals, which as an exercise physiologist you won't measure that much very often. But what can we measure with a single lead like this? We can measure PR interval and QRS complexes, which are two very common intervals that you will measure, and they can tell us quite a bit. Now, I'm not going to get into what an abnormal reading is going to tell us. I will do that in another video. But as far as what a normal reading should look like, we will 100% cover that. So your P wave, again, begins right here. When you measure the PR interval, remember an interval always contains a wave and an isoelectric area. An isoelectric area means that there's no positive or negative deflection. Which, also on that note, if you notice this black line, and you notice how all the isoelectric areas fall on that black line, that's called your isoelectric line. That's going to be your reference line. Now, it's not always going to fall quite so cleanly, and I'll show you what I mean. For PR interval, you're always going to measure from the start of the P wave to the start of the QRS complex. So it's this entire area. Remember, PR interval always contains waves and isoelectric areas. A normal PR interval should be less than 0.20 seconds, or less than one big box. Again, this is not drawn to scale, so when it's on paper, imagine everything is shrinked down. And this PR interval is. So if we start here and we count the number of little boxes, 1, 2, 3, 4. So 0.16 seconds. That's a normal PR interval. In electrophysiology terms, what that's telling us is that it's taking the electrical current the normal amount of time to travel through the atria and the atrioventricular space before it reaches the ventricles, which is the QRS complex. Now the QRS complex should measure less than 0.1 or 0.12 seconds. That depends on which textbook you read. I always go by 0.12 as being pretty much borderline elongated. So with this one, so let's see. The QRS complex starts right here, and we go one little box, about two little boxes. So this is a 0.08. That's a very, very normal QRS complex. So again, what that's telling us is that it's taking the electrical stimulus, the quote-unquote normal amount of time to travel through the bundle branches and Purkinje fibers and innervate those ventricles so that hopefully they can contract and eject blood. I also have marked up on here a QT interval with a bunch of asterisks. QT intervals have to be heart rate based. So different heart rates have different normal QT intervals. It's kind of like a tier setting. So we don't measure QT interval very much, but if we were to measure it, it's the start of the QRS complex to the end of the T wave. So start of the QRS complex to the end of the T wave. And what I would do if I was going to measure this just with a very basic method is I would cheat and say, okay, well, I see the QRS complex starts right here, and I see that the T wave ends over here. Now I see one big box, one black line to black line, so I know, okay, there's 0.2 seconds, and then I would go 1, 2, so this would be 0.28 seconds, because remember, 0.04, 0.08. Now, another little note here, that for all intent and purposes, these, you don't reset. So if you look up here, 0.04, 0.08, 0.12, 0.16, 0.2, this goes back down then to 0.04. This doesn't go to 0.24. It goes back down to 0.04. If you're measuring one continuous interval, like say the QT interval, then yes, you would have one big box, which is 0.2, and then add 0.04 and 0.08, which would be 0.28. However, if you were measuring your QRS complex, and you have 1, 2, then it's 0.08. Okay? Or, for example, if this P wave did not line up very nicely, like I made it here, if it, let's say your P wave started right here, and it ended right here on either side of this big black line, that's okay. Okay, let's say it started here and went to here, 1, 2, 0.08. So that's the best way to go about the measuring. So that was a very basic introduction. Remember your calibration. Always, always, always check your calibration first. 10 millimeters, so 10 of these small boxes in amplitude, should come out to 1 millivolt. The paper should be traveling at 25 millimeters per second. And again, remember when you look on it at an EKG, this is not drawn to scale, so it's going to look very different. But one more time, the PR interval is the start of the P wave to the start of the QRS complex. The QRS complex is the start of the entire complex to the end of it. It should be 0.12 seconds or less. All right? So I hope that was very helpful for you guys today. Keep a lookout for my other EKG videos.